All right, so a thing that you ought to be able to do to analyze data is you ought to be able to use a program like Google Sheets or Excel or something to plot data, and most importantly, to come up with a line of best fit. So I want to show you how to do that. All right, so you guys have just finished doing this friction lab here, right? And you've gathered some data and put it into your digital file here, right? So what I want to do is at this point, so like for static friction, for example, you've calculated for a whole bunch of different trials, you found what your normal force was and what your average maximum static friction was for those, okay? And remember that your maximum static friction and your normal force are related by a coefficient of friction. So what I want to do is I want to find the coefficient of friction between your shoe and the table that we dragged it across, okay? So one way to do that would be to, for each of these trials, just do, maximum friction equals coefficient times normal force and solve for your coefficient. But that would give us a different coefficient for each of these trials, right? And that's not what we want. And the point of doing multiple trials is that it allows us to sort of average out the error. Okay, so here's what we're going to do, is we are going to make a graph where we graph normal force and the maximum static friction as a function of that normal force, right? So over here, I've gone through and put in some garbage data. Your data may or may not look like this. I don't know, because I just made these numbers up arbitrarily. And hopefully they don't look like this, because it doesn't actually give you very good results. All right, but so what we want to do is we want to put normal force on the x-axis. So I always, every time I make a spreadsheet like this, I put the force, the variable that I want to be on my x-axis, I put that first. And then any other columns that I want to graph against that, I put afterwards, okay? So here I'm going to actually graph two different things on my y-axis. I'm going to graph maximum static friction and kinetic friction, okay, as a function of what the normal force is, okay? So to do that, all you do is you highlight the areas that you want to graph, okay? Notice I did grab the column headers here, okay? So I started here in this cell, and oops, sorry, and I highlighted everything from there down to this corner over here. Okay, so what I'm going to do now is I'm going to go over here to insert, and we want to insert a chart. I'm frustrated that they use the word chart, because to me this whole sheet is a chart, and what we're actually inserting is a graph. Okay, so we're inserting a graph, so I'm going to go ahead and click chart here, because that's what they call it here in the world of Google, and I think Excel does the same thing. And I'm going to click chart, okay, and it gives me this stupid thing, which is not at all what I want. And basically what it's doing is it's just graphing as a bar graph the magnitude of the normal force, the static friction force, and the kinetic friction force for each of my trials. But that's not what I want. Okay, so what I'm going to do is I'm going to go over here and I'm going to go to Customize. All right, and the first thing I'm going to do is I'm going to change my chart style. All right, and I'll be honest with you, I think the only time I've ever... Oh, sorry, I lied. Go back to data. Sorry. I don't want to customize yet. So I'm going to go to this where it says chart type. All right. And I'm going to be honest with you. I think the only type of chart that I've ever actually used is down here. It's called a scatter plot. Okay. And what it does is it just plots an X and a Y coordinate for every point. Okay. And both Excel and Google will always assume that your first column is the X value and the other columns are different Y values. So I'm going to click scatter chart, and it gives me this. All right, and so what it is here is each dot here represents a point. So this blue dot here corresponds to a normal force of 1 and a maximum static friction of 2, right? So that dot right there is this data point. Okay, and then right below it, this red dot corresponds to a normal force of 1 and a kinetic friction of 1.6. Okay, so what it's done is it's gone through and it's plotted an XY coordinate for everything. Okay, but the graph is still not sort of very pleasing, right? So what I want to do is kind of clean it up a little bit. All right, so the first thing I'm going to do is I'm going to, so if you click open the graph, I guess, oh, you just double click on it. So cool. So anyway, get this window open, and we want to tweak some stuff. So first of all, let's move this graph over so I can see what it's doing as I edit it. So Okay, yeah, so it already did this. It used my first row as headers. In other words, it realized those were...
Staff and students. At this
All right, sorry about that little announcement there. Okay, so it used row 1 as headers here. Also worth noticing that if you, for some reason, you have your columns in the wrong spot, you can sort them here. Like if you don't want the x-axis to be normal force, if you want it to be something else, you can edit that here, but I'm not going to do that. Okay, so that is that. So the next thing we want to do is now customize. All right, so chart style, this is just where you can change the background color and you can change your fonts and all that kind of stuff. I'm going to use Comic Sans because I know it makes students angry and I think it's really funny. All right, so the next thing, chart axis and titles. Oh, this allows me to put titles on my graph and on my axes. All right, so let's do this. First of all, let's give the chart itself, the graph itself, a title. So this is, so I clicked chart title, and now I'm going to go here and I'm going to type in a title for my graph. So I don't know, something like static and kinetic friction as a function of normal force. And I guess it's not really static friction, it's maximum static and kinetic friction. Okay. Oh, but now that looks kind of ugly because it's too big. So let's change the size to something a little bit smaller. Okay. Now, I want to label my axes, right? So let's go down here and change the horizontal axis. So the horizontal axis is our normal force, measured in newtons. Okay. And our vertical axis is friction force, also measured in newtons. Okay, and notice it added those little axes in. Okay. So let's see, what else? You can change your colors and all kinds of stuff. Maybe I want to make this red, although I wouldn't because that might be confusing. So I'm going to actually leave it black. But whatever, you can change colors and you can change fonts and you can bold stuff or put it in italics or whatever. It's all kind of straightforward. All right, let's go down to this next thing, series. So there are two series here. There's the maximum static friction one and the kinetic friction one, right? Okay. So I'm going to come back to this in a minute. In a minute, what I'm going to want to do is I'm going to add in a trend line. All right. Trend line is Google or Excel speak for line of best fit. Okay. So this will actually do that. But if you ever, suppose you couldn't print in color, right? Like right now, these are color coded, but maybe you can't color code them. So maybe you want them different. So maybe I just want to take my maximum static friction and I'm going to use triangles for static friction, and maybe I'm going to use, for kinetic friction, maybe I'm going to use stars or whatever, okay? So you can change those things. I don't like the triangles, so I'm going to change those to diamonds. Okay, so there you go. So that way, if you are printing in black and white, you can still do that. All right, so I'm going to come back to series in a minute. All right, legend. This just allows you to position this thing where it, explains what's what. Oops. All right. So that's legend, horizontal axis. So this is big. See how the horizontal axis only goes from 1 to 2.5? I really want my normal force to go all the way down to 0 because I kind of want to know where this line hits the normal force axis. All right. So I'm going to, notice up here, horizontal axis, font size, blah, 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 blah. I'm going to tell it that I want a minimum value of 0. And what it does is it rescales stuff. Okay. Cool. So that's that. Do you know what? I'm going to actually go up to, I don't like that this ends at my last data point, so I'm going to change the maximum value to 3. Okay. Now, you can see it changed these grid lines, and so we'll get to all that in a minute. All right. So there's my horizontal axis. My vertical axis, it allows you to do the same thing, but I'm actually pretty happy with this. The vertical axis goes from 0 to 6. 6 is not too far above my maximum value, so I think I'm good with all that. All right. Next thing, grid lines. All right, so I don't like the way Google does this. I actually like it better on Microsoft, but not everybody has Microsoft, myself included, so we're going to go cheapy. All right. So let's do horizontal axis first. So there are two types of grid lines. There are major grid lines, those are the ones that are numbered, okay? And there are minor grid lines. So right now, it's auto numbering this axis, and it's not putting any marks, sort of hash marks, between the big numbers, all right? So I think that I would like, right now we've got, well, let me see. I always forget how this works. So basically what you're doing is you're telling it how many of these grid lines you want. And so I don't know if it counts this as a grid line or not. So we've either got 1, 2, 3, or 4 grid lines, right? So if we do 3, let's see what that does. Oh yeah, so it does count the end one. So I don't want that. So if I do 4, then it gets me back to where I was. But I want to insert one at each half mark too. So I think I want a total of 1, 2, 3, 4, 5, 6, 7 major grid lines. Okay, so you got to be careful though, because if you do something weird, like if you do 6, then it gives you this, right? Or if you do 5, then it gives you that, right? So you got to kind of, figure out what makes the most sense. All right, now I also want some minor grid lines. So maybe I want a hash mark at every, I feel like doing every 10th would be too much. So let's do 1 between each, okay? All right, cool. So that's that. The major grid lines, I like those to be black. The minor grid lines, I like to be a lighter black. All right, and then I'm going to repeat the same process for my vertical axis. So my vertical axis, let's do 8, right? 0, 1, 2, 3. Oh, no, I guess just 7. So it happens to be 7 again. So let's go 7, and then let's put in a minor grid line for each one at a half. All right, cool. So that graph looks a little bit nicer. It allows me to tell a little bit better what these points are. I'm going to change these to be black, and I'm going to change these to be a lighter black. That looks pretty nice. Cool. And then you can always, you can click on stuff in here and change it there, that kind of stuff. Yeah, okay, cool. So there's my graph. It looks pretty nice, okay? Now, next thing you want to do is once you've kind of got your graph set up the way you want it to, now you look at the points. And it looks like both of these data sets, both the blue data set and the red data set, seem to suggest a straight line. Okay, so I'm going to go back to my series now. Remember up here I said I was going to talk about series. We're going to put in our trend line now. Okay, so you can either apply it to one series, the other, or I actually want to do a trend line for all the series, one for maximum static friction and one for kinetic. So I'm going to go ahead and select all series, and I'm going to click trend line. And what it does is it puts in these lines, and these lines are actually the line of best fit. Okay, now hopefully when you do this, your line of best fit will go through the origin. And if not, that tells you that there's a source of error, or maybe there's a force that you haven't thought about, or whatever. But there you go. All right, but we want to know what this line of best fit is. So notice you can change it here. So you can do linear. Sometimes maybe you want a polynomial, right? Like maybe I say, oh, this is a polynomial of degree 2, if it looks like it's, a curved graph or whatever. But this does look like it's linear. So there's different, kind of ideas here. So anyway, we're going to stick with linear for this one. It's already set to automatic color. I don't like it being opaque. So I'm going to darken those up a little bit. You can change the thickness and that kind of stuff. Now, how do you want to label it? Well, right now the lines are not labeled. So one thing you can do is you can give them a name. Okay, and you can go here and type in, your name. What I'm actually going to do, though, is this. Where'd it go? Oh, series. I lost it. There we go. Okay, so I don't want the label to be custom. I want to use the equation. So now what it's done is right here, it's given me the equation for this thing. Okay? So keep in mind that, and I'm going to do this. I'm going to go over to the smartboard for a minute. All right, so now if I look at my graph, what it's telling me is the slope of that blue line is 2.11, which you will quickly see is not very realistic. All right, so in blue, here's what I know. Remember, I know that my force of static friction max should be my coefficient of static friction times my normal force, right? And this is telling me that my force of static friction is 2.11 times x, which is my normal force, minus some y-intercept, v. So ideally, we want this to be 0, right? And it looks like this according to my data, my garbage data that I made up, it looks like it's telling me that my coefficient of static friction is 2.11, which is obviously not right. Yeah, your coefficient of friction should not be that big. Okay, so again, when I set up my data here, I want you guys to figure out your own data. So I didn't want to give data that would look like what your data was. And so, these, here, let me embiggen this again. Oh, there we go. So this data that I've selected over here is obviously incorrect, right? I've got my static friction being more than the normal force, which just doesn't make sense, right? But anyway, so that's, oh shoot, that's not what I wanted to do. So anyway, so that's how you create a graph, all right? And once you've got your graph done, what you can do is Control C, and then go to your digital file over here. Oops. You might not have this stuff. I haven't quite finished writing this lab yet, so if you don't have that stuff down below. But anyway, you can insert your graph there. And what it'll do is you can actually link it to the spreadsheet if you want. And so what that'll do is, so I'm going to do it linked. Usually when I create stuff, I actually do it unlinked. But this time, let's see what happens. We're going to click it linked, and I'm going to paste it. So here's my graph. But what this does is this way, suppose I realize, oh no, I made a mistake. I can go over here and change my graph. Maybe I discover that these numbers are all double what they should be. Or, whatever. I'm going to stop there. You get the idea. My graph clearly changed. So now when I go back to this, it gives me this thing that says update, and it updates it. Okay? So anyway, so that's that. There you go.